Hello and welcome to part 2, day 2. We're going to continue our discussion on writing using a geometric series to write a power series for us. Remember, this is a manipulation technique, so instead of having to take all those derivatives, just to make it a little bit shorter for us. So what we're going to do, remember, we are going to be centered at 0, so this is a nice one. So remember, that's named after Maclaurin, for a Maclaurin polynomial or Maclaurin series. And what we're going to do, we're going to use the sum of a geometric series. Now remember, the sum formula for a geometric series is the first term, over 1 minus r. And we compare that to our actual function that they gave us. And that tells us what all the parts are. For example, our first term is just the numerator in this case, which is 1. Now, in the next example, it's not going to be that. Our bottom one here, r, that's our common ratio, is x squared. So r is x squared. Don't worry about the sign, it's just a number for it. So when I want to write out my series here, I can write this out as 1 over 1 minus x squared equals, now it's not a squiggly. We'll talk about that in just a moment, why it's an equal sign instead of a squiggly. I can write, in other words, this is my Taylor polynomial, and it says I can write 1 over 1 minus x squared as, expanding my geometric as 1 plus x squared plus x to the 4th. Remember, I'm just multiplying everything by x squared here, plus x to the 6th. We generally go out 4 terms. Now, if I were to stop here, we would have to put a squiggly. It would be an approximation. But to make it a series go on forever. So I put this plus dot dot dot. And that's going to equal my actual series itself from 0 to infinity of just 1 times x squared to the n. And you can write that as just x to the 2n if you like. Remember, you can write this as 0 to infinity of just x to the 2n if you like there. Now, one thing the AP is going to be looking for, 1, do you have your first 4 terms? And 2, do you have the general term? So you need both of those. Well, let's take a look at another one, a slightly harder one right here. And for this one, we're given the function y equals 1 over 4 plus x. Now, since I'm given this y equals 1 over 4 plus x, remember, I want to write this as a geometric series. In other words, I need the form, the first term over 1 minus r. It's not like that just yet. So I'm going to have to manipulate this. So what I do is I like to write it this way: 1 over 4 plus x equals a sub 1 over 1 minus r. Now the first thing I notice, not that the first term is 1, it's not. It's this. This one right here is now a 4. That 4 must be a 1. So how do we get that to be a 1? We divide. So this becomes 1/4 over 1 plus x over 4. Remember, I'm going to divide everything by 4. And that's still equal to this a sub 1 over 1 minus r. Now, what I next notice is this negative right here, this minus sign. This minus sign over here is a plus. So we have to change that. And I can write that as 1/4 over 1 minus a negative x over 4. And that's equal to a sub 1 over 1 minus r. And now I have everything. This is a 1, and that's a minus. So now I can write out my series. Well, what is my first term? Well, my first term is this 1/4. What's r? r is this negative x over 4. So you notice this is going to be an alternating series because r is negative here. So now I can write my series. 1 over 4 plus x will equal, now why is it an equal sign? Well, remember, if I stop here, it's going to be an approximation. We would use a squiggly. But the plus dot 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 tells me it's a series, it goes on forever. And if you take an infinite number of these terms, you actually get the exact same function. Now if I expand this, remember my first term is 1 over 4. I'm going to multiply that by negative x over 4. That becomes a minus x over 16. Multiply that by negative x over 4, so plus x over 64 minus, whoops, sorry for my x, this should be x squared, minus, again, x cubed over, 256. And then plus Now to get it to be a series, dot, dot, dot. That's why I want that equal sign. It's a dot, dot, dot. It goes on forever. And that's going to equal my actual series itself. And how do I get the actual series? It's just my 1/4 times negative x over 4 to the n. I ran out of room there, but you can kind of see that right there. Now again, if you wanted to, you could write this. You can take out the alternating part, negative 1 to the n, 1/4, and then I multiply that by x over 4 to the n. Both are acceptable. Alright, so let's take a look at one more example, and this third example, I'm sorry to say, but it's a hard one, okay? For the third one, let's let the function this time be 15 over 2x minus 1. So not only that, but here's what we're going to do. We're now going to center at x equals 2. That's going to be a little bit tougher for us. So what matters is, remember, if you think of a center as a horizontal shift, I'm shifting my x. Now right now my center is at 0. So what I need to do is I need to shift this, in this case, right 2. We need to shift right 2. And you may recall from Algebra 2, when we do this, this becomes 15 over 2 times x minus 2 minus 1. I shifted it over 2. There's my c value. But here's the problem with doing this. I changed the value of my fraction. This is now, I'm subtracting 4 units from here. So I have to fix it. I have to adjust it, and I'm going to add 4 here. This adjusts the minus 4 that we just subtracted from here by shifting it horizontally. And I can reduce this a little bit. This becomes 15 over 2 times x minus 2. Be careful. Plus 3. And now I'm going to start manipulating it. It's going to be equal to my first term over 1 minus r. I need to get this exact thing to look alike. Now the first thing I'm going to do, I'm going to switch my places here. It's 1 minus r. That's my r, but I got to switch it around. So I'm going to write this as 15 over 3 plus 2 times x minus 2. And now, same as before, there's my first term, 1 minus r. I want this to be a 1. So I'm going to divide everything by 3. So we're going to divide by 3 here. So I get 5 over 1 plus 2/3 x minus 2 equals this a sub 1 over 1 minus r. So I got rid of that. I got that. That's a 1 now. Now the only thing I have to deal with, this has to be a minus sign. And we did that in the last problem. That was pretty easy. So this becomes 1 minus a negative 2/3 x minus 2 equals a sub 1 over 1 minus r. We are now ready to write our series out. Well, what's my first term? That's this 5. So I know a sub 1 is 5. My common ratio, I just match it up with the like part. It's a long ratio this time. It's negative 2/3 x minus 2. And what we're going to do now is expand it. Well, so my original 15 over 2x minus 1 can be equal to, my first term is 5, minus, be careful, 10/3 x minus 2. Remember, I'm going to multiply everything by 2/3 here. Plus, because it's also going to alternate, I'm going to multiply this by negative 2/3. That becomes, what's that, 20 over 9 x minus 2, be careful, squared, minus, multiply by another negative, whoops, that's a squiggly, scratch out. This becomes minus 40 over 27 x minus 2 cubed. Count up, 1, 2, 3, 4 terms, plus, now it's a series, we go dot, 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 equals, from 0 to infinity, and then we're going to plug it in. Our first term was 5. We multiply that by this negative 2/3 x minus 2 to the n. And remember, if you don't like it this way, it is alternating, so you can take out the negative and write it this way. Negative 1 to the n times 5 times 2/3 x minus 2 to the n as well. Yucko. Alright, well anyways, hope you guys had fun today, and I'll see y'all later. Bye-bye.